Hi guys, welcome back to my channel Pirai Academy. In this series of Zoho interview question, today we are going to see a question called matrix diagonal sum. It is Leetcode question number 1572. Given a sequence matrix, return the sum of the matrix diagonally. Only include the sum of all elements on the primary diagonal and all the element on the secondary diagonal that are not part of the primary diagonal. Fine. So just see an example. This is the matrix, okay? And here, what is the primary diagonal? Primary diagonal is something like 1, 5, and 9, like this cross. And secondary diagonal is like this cross, this 3, 5, and 7. But here we do not include any element from the primary diagonal to the secondary diagonal. Okay, so this 5 will not be included. Okay, in the secondary diagonal. So what is my sum? It will be 1 plus 5 plus 9 plus 3 plus 7. Can you understand this? Yes. So for example, if this is the matrix, then I can say the primary diagonal of this matrix is this 1 1 1 1 like this, and secondary diagonal will be 1 1 1 1. There is no common points for primary diagonal and the secondary diagonal, so we don't want to exclude anything. Okay, we will be including all the elements. So what is its sum? It will be 8. Hope you understand this. Fine. Now how to do this? It is so simple, right? First of all, we can see what is a brute force approach. That will be the initial thinking. Okay, so the brute force approach is like each and everyone will be thinking like we want to iterate over the matrix, okay, and check for the diagonals. Like this is one of the diagonal, right? From this to this. Yes, so this is one of the diagonal, and then this is the secondary diagonal. Yes, now just look at the numbers, like this row and column numbers. Okay, it is 0 comma 0, it is 1 comma 1, it is 2 comma 2, this is 3 comma 3, this is 4 comma 4. From this I can say what? If row is equal to the column, then I can say what? It is a primary diagonal. So I will be taking all these element and just adding it. Okay, and also what is the relationship between this secondary diagonal? It is 0 comma 4, 1 comma 3, 2 comma 2, 3 comma 1, and 4 comma 0, which means while I am adding the row and column, it will be resulting in the number of rows minus 1. What is the number of rows here? It will be 5. 5 minus 1 is 4. So when it is also satisfied, then I want to take this as our account, as our result, and I want to check whether there exists like this a common point. If there exists any common point, then I will be subtracting this common point once. Okay, so this will be leading to time complexity of O of n square, and what is the space complexity? It will be O of 1, because we haven't taken any auxiliary space, right? Okay, whether we can optimize it. Okay, just see this carefully. What is the logic, or what is the just observation you have got from this matrix? It is like at first I will be taking this and this in the 0th row, and then this and this in the first row, and this alone in a second row, and this in a third row, and this in a fourth row. So which means I am taking two extremes. Okay, here I am taking second element and the last second element. Here I am taking the third element and the third last element. Here I am taking the fourth element and the first last fourth element. Can you understand this? Here I am taking the fifth element and I am taking the last fifth element. Can you understand this? Right? So from here we will taking, if those both values are same like this, okay, then I will be taking only this, or else I will be taking the sum of this 7 and this 9, this 5 and this this 1 and this 5, 17 and 19, 21 and 25. Can you understand this? Yes. So here if I am iterating over this all rows as I, okay, then this I will be 0 1 2 3 4. Okay, if I am iterating, then I will be taking the sum as I and n minus I minus 1, because at first I will be taking 0 comma 4. right? Like zeroth element and the zeroth index element and the fourth index element at this row, right? So when I is 0, what is this expression? N is 5, 5 minus 0 minus 1 will be 4. I will be taking the 0th index and the 4th index element in the row 0. When I is 1, I will be taking 3. When I is 2, I will be taking again 2. At this point, we do not add again this 2. We only add one time of the second index. Then next, it will be something like here comes 3, here comes 1, here comes 4, here comes 0. Can you understand this, right? So for this approach, what is the time complexity? Time complexity will be over n, because we are just iterating over only I. But in the previous approach, we are just iterating over I and j. Like for each and every row, we are just go on and traversing each and every row and column matrix in the previous approach, brute force approach. But here we are just iterating over the rows. Okay. Fine. Now, what is space complexity? Space complexity will be over 1. So this is the time and space complexity analysis. Let's see the optimized code so that it will be more clear. See here, first of all, s is equal to 0. So this will be a result. And then int n is equal to matrix dot length. So I am taking the number of rows and number of columns as n. Okay. And for just I am iterating over the rows. I am iterating over the rows and picking j as n minus I minus 1, which means I am just taking I, comma, n minus I minus 1, right? In the drawing explanation. Like that here also I am taking. Now I will be first adding s plus is equal to matrix of I and I, which means I am taking the primary diagonal. Okay. And if this condition satisfied, what condition? I is not equal to j. Okay. Then only I want to add the secondary diagonal. Can I understand this? Yes. At last, I will be returning the yes. Let me submit it. Yes, it is submitted successfully. To know about these kinds of algorithms, just go and search in my YouTube channel. And if you really like this video and subscribe to my channel. Don't skip any videos in this playlist. Just watch each and every videos to crack this Zoho interview question. Thank you.